that might happen, right? If you look at VMware today, they've always been great at calling a software-defined API to find out how many servers there are, and how many CPUs are in each server, and how much memory is in each server. And then they can take the application and look at the usage of that and put it in the right place. They've been doing that for over a decade. And they can move it based on changes in the infrastructure automatically. A couple of years ago, VMware acquired Nicira. Nicira does the same thing at the network switch layer. It can discover how many switches there are, how many ports are on each switch, what are the capabilities of the switch, how much is currently allocated to the application. And then VMware can place the application in the network, and this is the last piece, right? If we can come up with a well-defined set of characteristics of what applications need, which is essentially what Adaptivity has done, right? For any application, they can describe at the storage level what are the needs, the data needs of that application. Then VMware has every piece of the puzzle to build a truly software-defined data center. And if we want to experiment with this, what better place to do it than at the Durham COE, which is a data center technology team. So I'd like you to build this. This is what I'd like you to build. Okay? The third platform, if you remember back to that initial definition, there are millions of applications that want to run on the IT infrastructure. And there's no way a human being or a team can place people, place the applications on the right form of infrastructure manually. You'll get yourself in that situation where the business applications that you're running are under-expensed or over-expensed, right? You either don't have them running on enough mission critical, or you have them running on something that's much, much too expensive for the needs of the application, right? And so this picture of a software-defined data center, combining all the technologies that EMC has in our federated portfolio today, VMware is uniquely positioned to deliver this first before anybody else, right? And the only concern, so we tell the customers, you really should be using 100% VMware, right, to get you to this type of operation. However, we recognize that there are a lot of service providers out there that are building their own data centers, trying to use as much commodity and as much open source as possible to save money. So if you have service providers that are using OpenStack to manage their infrastructure, how are you going to move your applications if you decide to place them in the cloud? So what I tell customers is VMware is one of the top 10 contributors to the latest version of open source OpenStack. So VMware is actually investing quite heavily in OpenStack's infrastructure to enable interoperability going forward. Okay, we're getting close to the top here. We've talked about a software-defined data center, and we anticipate there'll be many different kinds built. You'll have a Google, you'll have Amazon, you'll have VCHS, you'll have your own private data center for whatever company you're in. The question then becomes, how do you build applications on top of this as fast as possible? So Vodafone, that example I gave you earlier, they built their application in weeks, right? So they could begin saving money immediately instead of waiting for 9 or 12 months. So Pivotal has 3 strategies for reducing that software development time. Number 1, give your application to Cloud Foundry for deployment so that your software developers don't have to worry about the specific hardware running inside that cloud, right? So that's what you can think of Cloud Foundry as a driver for deploying your application. You don't worry. You don't write about, well, where is my file system mounted and what storage system and what server am I going to use? Cloud Foundry automates all that, and therefore your application developer doesn't have to worry about it. Number 2, there's a data fabric. There's a tool set that Pivotal has built into Cloud Foundry where you have access to terabytes and petabytes of data at your fingertips with these APIs. If you like to write Java MapReduce APIs, you can use Pivotal Hadoop. If you like to use structured SQL queries and run that against HDFS, they have a converter that goes from SQL to unstructured HDFS, MapReduce, and back again. If you like to do in-memory streaming analytics, they have an API for Gemfire. So that's the second thing, right? This tool set that's very easy to access all of your data, regardless of where it sits. And then finally at the top, we have all sorts of software development tools, VMware vFabric, Rails, Node.js, RabbitMQ, Redis, all these things in the Pivotal portfolio that are agile, fast software development tools. But the big one is Spring. Spring is one of the most popular Java application development platforms in the world. And the team is building all of these reusable big data components so that when our customers write an application, they don't have to do a lot of grunt work. If they want to create a network, attach a network sockets or some sensors to the Hadoop file system, they get a component from Spring and they drop it into their application. Right? So all three of these things help our customers build their new applications very quickly. The last piece of the puzzle is mobile applications. On the left here, you see the traditional way to take file content and drive it into an IT infrastructure. Very static. You know where your storage system is. It's either a block or a file storage system, and you mount an E drive or you mount a home directory. That's not going to work for a customer that has 10,000 mobile users scattered all around the world. So we're telling our customers that when you build your third platform infrastructure using the building blocks that we already mentioned, you have to have not file, not block, but strong object-based semantics. On the internet, these mobile devices are doing HTTP, put, and get, which is essentially an object-based interface. So the underlying infrastructure has to have the ability to support object, which is, again, our Viper, right? That's a Viper. All three of these are Viper icons up here. At the same time, if you look at the user interface on the mobile device, that's EMC simplicity. And when compared to the interface on the left, it's much more fluid, it's much more dynamic. There's so much more content that's being shared, you need to spin those folders with your finger to find things. Or if you want to share a document, you say, I want to share it with all the people that I was in that last meeting with. I don't want to look up their NT IDs and give them permission that way. I want to click on their faces from my calendar. So these are social applications, and simplicity is a great use case for how a social mobile app should be written. And the last point here about mobile is, if I'm ingesting all that data from the internet through an object interface down to an infrastructure, and I want to use Hadoop to analyze it, I don't want to pick it up and move it over to the Hadoop file system. I want to be able to analyze it in place using whatever protocol I brought it in the first place. And that's what Viper does. You can bring in data using one protocol, file, object, and you can pull it out using a different protocol, for example, HDFS. The big finish, right? Remember the context. I'm talking to customers. They're about to write a big check for a VMAX VNX. What is this third platform? How do I build it? And we say, listen, you just take all the stuff we already have and you mix in some of the latest industry trends. And it's all managed using the same software-defined storage layer. And at the cloud orchestration layer, we have answers with VMware. We have answers with OpenStack. And so you can operate them simultaneously. Now, if you want to move data back and forth, some customers say, well, aren't I going to move all of my applications and my data eventually over to the third platform? And my answer is, I don't think so. Maybe you could get there. But if you